Thank you very much. Is it coming through the mic okay? Okay, cool. I did briefly turn it off while I left the room. Yeah, as you can tell by my voice, the London he's referring to is not London, Ontario. It's the big one, the original. I feel very fortunate to now live in Toronto. I moved here in March. I love the city, and it was really cool. This is my first talk that I've actually done here. It's funny, when you move somewhere, you tend to travel more away from it to do talks, so this is really cool. TypeScript State of the Union. There's union types in TypeScript, so I kind of felt like that was a nice way to weave that in there. Maybe I should have done State of the Union type. But essentially what I wanted to talk about, because I feel like this maybe hasn't been brought up for a while, is just readdressing TypeScript, and particularly at a conference like this one, where we're talking about all kinds of topics which affect development and JavaScript development and as a whole. I think TypeScript might be one of those things that you've come across and maybe discounted as not being the right thing for you. Maybe not helpful for your particular situation, maybe too complex, maybe too different from the JavaScript that you know and love. So I want to try and readdress that today and maybe reintroduce you to TypeScript. And we'll cover a little bit about what the state is on our current version 3.1, and what that's like to get started with when you already know a bit of JavaScript, when you already know how to get started with JavaScript. How can we add TypeScript to a project? How can it help us write the best JavaScript we can? So my obligatory, my slides aren't coming up yet. Just imagine what my slides look like. They're great. That was blue. There we go. That's my Twitter handle. Stuff we've done the About Me, so you can look me up online. I have some TypeScript courses on TypeScriptCourses.com. So you can learn TypeScript in depth from start to finish if you want to after the talk. And the things I want to chat about today is I'll just bring you up to speed on the history of TypeScript, how we got here, some of the major milestones that have happened in the project, what TypeScript looks like when you compare it to JavaScript as a language, a little bit about how it works, so some of the core pieces of the framework, and how the different bits of architecture help you when you're writing your code, and some of the latest and greatest from the project, from the team, from the open source community, and some of the things that might be coming up in the near future. So how many people in the room have used TypeScript before? Oh, a lot more than I was expecting. That's really cool. So I will try and make it a little more interesting to you, but it may be useful for you to see some of the things of how we introduce TypeScript these days in the project, because it has changed quite a lot. There's a lot more power there now. So literally only yesterday, the TypeScript team tweeted that it's 6 years old. It's happy birthday to TypeScript as of yesterday, which is pretty cool. So it went straight into my slide deck. I think it's crazy to think that the project is that old and doing so well. The growth curve of it has been truly incredible. If we look back at the early days, in 2011, there was this internal project in Microsoft called Project Strada. And the scope was pretty broad. It was about bringing all kinds of power to JavaScript applications because the engineers at Microsoft were struggling to build applications which scaled. Unusually for Microsoft at the time, because if you think about what Microsoft was like in 2011 versus what we know about it today, open source was not really a core part of how Microsoft operated. They were kind of the kings of proprietary stuff and locking things behind proprietary firewalls and that kind of stuff. But the Strada team, Anders Hallsberg in particular, recognized that going open source very early on was going to be important to the success of the project. It wasn't quite the open source that we know today. They used a Microsoft tool to be open source, and it was kind of like, yeah, you can see the source, but you're not going to be contributing to this thing. You can look at it, but we can't accept PRs or anything like that. So that did start to change when they moved to GitHub in 2014. So they launched in 2012, as we know, yesterday, 6 years ago, and they refactored their parser a couple of steps along the way. And then in 2014, they finally moved to GitHub. So that's when it moved from being just open source to what they would describe as open development. Now, anybody from the community could open a PR file, an issue. It would be in the same arena as the developers working on the project itself, which is really, really cool. And then I would say that probably the next most significant milestone came when Microsoft and Google worked together when the Angular framework was going through its major rewrite. So AngularJS became Angular It was version 2 of the framework. They kept the same name, dropped the JS. Angular, they really wanted to build in some extra features on top of JavaScript. So they were going to build their own proprietary language called AtScript. And basically, AtScript was just a tiny amount of features on top of what we already understood to be TypeScript. So fortunately, they were able to work together. TypeScript introduced the missing features into TypeScript, such as decorators, and Angular was able to be written in TypeScript instead of being developed using a proprietary language called AtScript, which was really, really good. And at this point in time, you could see that both the framework of Angular and the language of TypeScript took off together, which is really, really cool. So as I said, TypeScript exists because writing scalable JavaScript applications is difficult. The strapline of TypeScript is to write JavaScript that scales. And I think one thing that is easy to conclude is that it's not the JavaScript that I know, it's not the JavaScript that I care about. But I think a core thing about TypeScript is it's not trying to replace JavaScript. It's not trying to reinvent the language. It's about embracing and enhancing it. And when we talk about the type system in a little bit, we'll understand how they've actually sacrificed some things from classical type theory to embrace the dynamic nature of JavaScript for the benefit of everyone that uses it. And the other key thing is that TypeScript has always been about empowering tooling. There are other statically typed tools for JavaScript. For example, Flow is an example, and they've taken a different approach to TypeScript. I'm not saying it's a better approach or a worse approach, they've taken a different approach. But one of the key things TypeScript always wanted to do was be able to use the knowledge of types to provide you with tooling to help you write your JavaScript code. So this is just borrowed from a slide from Anders, the kind of godfather of TypeScript, and these are the key points that they want to strive towards in their project as maintainers of TypeScript within Microsoft. So as I mentioned, it's more than just open source. They want to develop in the open. They want people to contribute to it, and they want to take feedback from the community wherever possible. In the very early days, there wasn't really a constraint on what can we add, whereas now they really want to track what ECMAScript, in other words, JavaScript, is doing. So features that get proposed for the language, like, for example, in ES 2015 or ES 6 as it was known originally, when we had classes introduced for the first time, they want to be compatible with any of those features that come into JavaScript, and they don't want to be ahead of that anymore. They don't want to be inventing proprietary TypeScript things in the language, which then don't match up with JavaScript, the language. Instead, they want to innovate in the type system. So that is their domain. Some of the stuff they're able to do in the TypeScript, in the type system, is mind-boggling and so, so cool. And that is their arena where they can experiment, where they can build really cool stuff. They're not going to be doing that with the core language structures and values. I mentioned about the tooling. They are actually part of the same organization within Microsoft that produces Visual Studio Code. How many people here use Visual Studio Code as their primary? Nice, cool. So we all benefit from TypeScript being a part of that same team. They develop with that team, and it means that they can really stay in sync with what's happening there. And community. This Anders mentioned this about Steve Ballmer going developers. They want to change it to community. So I'll talk about that in a little bit. Crazy popular. One of the C-level people from NPM did some research based on a survey of more than 16,000 users. 46% of them reported using TypeScript. So I think TypeScript's done a really good job of being a part of the NPM ecosystem without trying to replace it and just slotting into the existing setup. So it's amazing to know that so many developers, obviously in a relatively small sample compared to the whole of NPM, but it's amazing that so many people are using it, downloaded over 10 million times a month. Very, very popular. Apparently more TypeScript projects were created on GitHub in 2017 than C++ projects even. So it's kind of crazy how much the growth curve has gone upwards. I've always wanted to be the douche that quotes himself on a slide, and I've never done it before, so I thought today was the day. So I tweeted this last night because I thought it was a really good point. I think the example I love to use when people talk about, I don't want to use TypeScript because I don't want to deal with types, is that types already exist in JavaScript, whether you choose to use tooling that can understand them or not. And the way I can prove to you that you deal with types all the time is with this line of code. Naturally, you don't usually literally write the value undefined and try and call it as a function, but ending up in a position where you are trying to call a value which has not been defined and therefore defaults to the value undefined, and you try and call it as a function, happens all the time. And if it wasn't enough of a clue that the type of error that you're getting is called a type error, if you look at the ECMAScript definition, the specification, as I know we all do before we go to bed every night, we read the spec, you will have, there's a whole section dedicated to the ECMAScript types. These are things like undefined, null, boolean, object, symbol, function. Those are the kind of types that exist in the language. They have corresponding values, and you don't deal with those types through syntax unless you use a tool like TypeScript. That's when you can start to take control of some of those things and try and get the tooling to protect you so that you don't end up at runtime getting this feedback. Instead, you get the feedback at author time. So with this understanding of types that TypeScript can give us, as I mentioned, they work closely with Visual Studio Code. It powers lots of different things we take for granted inside of our editors. If we didn't have an understanding of the types of our programs, we couldn't jump to where they were defined. We couldn't be typing the method name and it auto-completes the rest of it for us. We couldn't automatically refactor code. We couldn't command-click or control-click on Windows to jump around our code base. It simply wouldn't be possible because behind the scenes there needs to be an appreciation of how the symbols in our program interact with one another. This exploded in popularity. I'm not a Vue developer. I've never written any Vue, but I happened to notice that the guy that created it, Evan Yu, he tweeted a blog post just announcing his plans for the next version of the framework, and he's actually going to be writing it in TypeScript. So even, I would say, even frameworks with JS in the name are going to be written in TypeScript behind the scenes. And one of the really powerful things about this is it doesn't change anything about the Vue.js development experience. It will improve it if you're using TypeScript, but if you're not using TypeScript, the fact that the authors have used TypeScript doesn't impact your code. And I think that's a really powerful property which relates to the tooling aspect which the TypeScript team have managed to maintain. So the knowledge of the relationship with Angular is pretty well known. I think they have a very tight relationship. The fact that Vue.js is being written in TypeScript from now on is really, really cool. At Google, there's only a handful of languages that are allowed to be used, period. You can't just decide I'm going to use Scala today or anything like that at Google. They very tightly control the languages that are available for use because they operate on this model of having essentially all of their code in one giant monorepo. So it wouldn't work at all if developers had the freedom to just add languages to that monorepo whenever they saw. They would break their tooling and break their assumptions. TypeScript has now been approved as one of the 5 or so languages that are actually allowed to be developed with at Google. So that shows how far it's come and the relationship with the team there. And huge companies are using React and TypeScript. So even though Facebook and Microsoft might not have had an explicit brain trust in the same way that Google and Microsoft did for the Angular stuff, the Microsoft team have worked hard to make sure that there is a special appreciation of React inside of the TypeScript code base. So since very early on, TypeScript has supported JSX syntax. They call it TSX because you use a .tsx file extension. But recently, they've really tried to improve the React development experience when you're using TypeScript as well. So that's, I think, a powerful thing. And it's being used at scale at Microsoft, but also other large corporations such as Slack. So if you're sat there thinking, well, I'm a React developer, so maybe TypeScript isn't the right fit for me, that's simply not the case. You can get an enormous amount of benefit from it. And there are, of course, many, many, many other frameworks. The slide would go on forever, but some big ones that are written in TypeScript, Dojo and Aurelia, there's plenty more. And of course, there is absolutely no requirement to use a framework of any kind. You can write very, very strong JavaScript code using TypeScript without any frameworks at all. So how easy is it to get running with TypeScript? That's what we're going to now see in a demo, hopefully. So hopefully you can read this okay. It's pretty bright. I definitely do not develop with a bright white theme. I value my retinas. So this is just for your benefit, I promise. So here we have a JavaScript file. I wouldn't pay too much. This is actually inside the project that is running my slide deck. So don't pay attention to the folder structure of the files too much. So I'll just move that over a bit. Oh, no. Now we're in trouble. There we go. Cool. So I have a function here. It's a pretty great program. I'm quite proud of this. So first name variable James. I'm going to be logging it ultimately, but I'm going to be doing a transform on it. I'm going to be turning it into uppercase. Who can spot the bug? Exactly. It's not easy. Humans suck at reading code and immediately understanding it as if we're executing it in our minds. It's not easy. I have deliberately written uppercase in the casing that I've written it in everywhere to even influence your eyes to think that that is the correct way of writing uppercase. So obviously you can write uppercase like that, but it means that it's influenced your thinking around this C. So this C should be a capital C. So this method to uppercase with this casing does not exist on the string prototype. So this would be a runtime bug that would make it all the way to production. You all passed it. You were all my pull request reviewers. You said approve. I merged it, shipped it to users, and it's broken. So how can we improve this using TypeScript? And I don't mean that we start installing the TypeScript compiler and compiling our code and having a dist folder, which we then need to... None of that. How can we just add a little bit to make our program better? So what we can do is TypeScript actually understands JS doc annotations. So these might be things that you've used in the past to document your code, but they can do a bit more than that because they have such expressive syntax. So if I add a param here, I'm not used to this syntax theme, so that looks correct to me. So if I had a param here, standard JS doc syntax, hopefully that is, I'm just saying the name of my parameter, I'm saying its type. If I now hover on S, you can see that Visual Studio Code somehow now knows that that's a string. So if I just take that away again, go back to my S, this was of type any before, because there was absolutely no way for it to know what the type was. But now I've added just a document, just a comment, a documentation comment, and the editor has been able to pick up that this is a string. So that's really, really cool. This is because even when you're using JavaScript directly, the TypeScript language server, which we'll talk about, service, we'll talk about a bit later on, is running in the background. So we still don't have any errors with our to uppercase. So even though things have improved a little bit, so if I were to use S here, I might be able to get some more information here, but we've not necessarily turned on all the error handling that we'd want. So if I move on to number 2, that's what our state looked like, good. What I'm going to do now is I'm going to still be using a JavaScript file. I'm not going to be adding the TypeScript compiler explicitly yet, but I'm going to go up to the top of the page, and I'm going to add another comment, which I'm going to be adding one of these flags to. This is TS_check. So if I enable TS_check, so it's a normal comment. Again, it's not affecting my runtime JavaScript code. But as you can see, what's now happened is that language service with the TypeScript compiler that was already running in the background, I've now told it with this comment, please give me things you know are definitely wrong. So it's not as precise and it's not as noisy, let's say, as the TypeScript compiler. When you run it completely, it's not going to tell you about everything. But things where it knows you've definitely made some kind of mistake, like with this method to uppercase, it's going to give you some feedback. So here you can see it's even been able to recognize it's doing some like fuzzy pattern matching on the methods which are available on that prototype, and to uppercase with a capital C matches the best. So it's even suggesting the fix for me. So I can come in here, I can fix the bug, I can reopen the PR. I've not changed our development pipeline, I've not changed our build process. All I've done is add 2 lines of comments to my JavaScript program, and now when I submit it to you and you all blindly approve it, it will go in and the bug will be fixed. So that's great. So far, we've got started with TypeScript almost without using TypeScript at all explicitly, which is really, really powerful. And these are some of the new things which have come to TypeScript within the last few years. So moving on to our next example, we are still dealing with I can't even remember what my next example was. Oh, I know what my next example was. So imagine now, I did this ahead of time just so that I wasn't wasting anyone's time, but imagine now that I've added a tsconfig.json file to my project. So the way that you would do this is you would install the TypeScript compiler via node modules. So I've done that. That's the reason I didn't want to do this live, was because installing from node modules on a Wi-Fi connection not easy here. So I've installed TypeScript compiler via node modules. I then can invoke, so I could use npx, for example, to invoke my local node modules, tsc --init. So if I run that, that will generate what we're looking at here. That will generate this tsconfig.json file. And as you can see, the way that they generate it these days is they add all of these comments explaining what the different properties do, what the different config options do, which is really, really cool. It used to be a little cryptic as to what all the compiler options did. Now they actually tell you. So if you're going to be starting a new TypeScript project, I would highly recommend you use tsc init. It's very, very cool. So all I've done here is I've uncommented the flag, which is allow.js true. So as you can see, this allows JavaScript files to be compiled. I've explicitly told it which JavaScript file I want to include in my bundle. But if I were to run npx tsc to invoke the TypeScript compiler, I'm not in the right folder. One of the reasons I'm using npx is so that it will traverse up to my node modules. So there you go. So I've set the out.dir to dist, and I've invoked my 4.js. So here you can see, this is my input with my ts check and my string comment, and this is my output. They are identical, essentially. All TypeScript has done has nicely added the useStrict directive for me, because I forgot to add that myself in the JavaScript code. But essentially, it's the same output. So all I would say to you is whenever you have these conversations at work or with your colleagues, this is how lightweight TypeScript has become on top of your JavaScript. Even when I do use the TypeScript compiler, I don't need to make it a TS file. I can still have it as a JS file. I can enable the flag allow.js true, and it will barely change the output of my JavaScript if I don't want it to. I can do more work on this file, obviously, as part of a build process, but this is fine for now. This is a good start. So I'm going to close this. If I wanted to go a step further and change this to be a TS file, here you can see what I've done is I've taken my js.comment and I've actually added it as a type annotation. So it's a colon string syntax instead of the param string in there. So it's now actually syntax in my program. And I no longer need the ts check comment, because if I were to make that same mistake, it's going to be able to tell me directly because I'm running in a TypeScript context already. Cool. So I'm sure I went on way too long on that particular example, but hopefully, I think that's one of the most key things that people have skipped, is we haven't gone back and taken stock of how easy it is to get started with TypeScript these days. So the type system itself, I think it's worth noting how impressive it is and how unusual it is. So the TypeScript, this is a duck typing, by the way, so duck type. I liked that, and also the fact that it looks like clip art from my homework in the 90s. So gradual typing. Normally, you would associate gradual typing with, you would think of it as a negative thing. So normally, the opposite of gradual typing would be the soundness of your types. So being able to say ahead of time that something can only compile if it's soundly typed. Whereas JavaScript, because it's the base of the TypeScript project and is such a dynamic language, applying the types gradually, and because the semantics of JavaScript are so clearly defined, you're not dealing with the same class of issues. If you were dealing with something where you needed soundness, for example, if you're dealing with direct memory access or something like that, then it makes sense to think about soundness as the primary goal. However, when you're dealing with something like JavaScript, a higher level of abstraction, applying the types very gradually allows you to be incredibly flexible around the approach, and empowers tooling like we just saw. The type system is structural, and here the opposite would be a nominal type system, for example, like in Java. But here we have structural typing, which you might think of as duck typing. And the concept of duck typing is if it quacks like a duck and it walks like a duck, it must be a duck. So if you have a shape in your program, and you have something else which can match that shape, almost like a contract, does it match the shape, then you can say that it passes type checking. So this allows us to do very simple things like the interfaces you might have seen in TypeScript. You can say, I can implement that interface as long as I have these two methods that this interface requires, then it works. So the structure is more important. As we've seen, there's a lot of inference that happens in TypeScript. It's able to infer from the way that you write your program. So that means that the type annotations are not a requirement. Your TypeScript programs don't need to look wildly different from your JavaScript programs. You don't need to annotate every single variable. It can infer the types quite well. But then when you do need to go as far as expressing very complex situations, for example, if you're a library author or a framework author, you might need to express very reusable functions which take multiple types of inputs, stuff like that. So the type system can be very, very expressive when you need it to be. So the TypeScript compiler is the thing that powers all of this stuff. It's the TSC binary that we've seen executed already. The TSC does a couple of different roles. It's the emitter, so it's the thing that takes my JavaScript source, it turns it into an AST, and it emits some other transformed version of that code. That's what it does as a transpiler. So it's a particular type of compiler at a particular level of abstraction. It also performs the role of type checking for you, and it's configured via a tsconfig.json file. So the TypeScript project itself has got lots of moving parts, but the TSC is our entry point into it. It's the only thing we really need to worry about. We install TypeScript, and we have access to the TSC command. One thing that I had enabled, because I started the project with TSC init, is strict type checking. I cannot impress on you enough how important it is that you have strict true set in your tsconfig compiler options. The reason for this is particularly the check called strict null checks. This was introduced in version 2 of TypeScript. And essentially before version 2, null and undefined were subtypes of every other type, meaning they could be assigned to any other type. So if you had a number or something like that, you could null it, you could set it to null, and that would be a valid assignment because null was a subtype of number. And that led to the TypeScript compiler not being able to class a whole category of bugs for you ahead of time. So it's not worse than JavaScript. JavaScript lets you do those assignments all the time because it's dynamically typed. But until null and undefined became their own distinct types, TypeScript wasn't able to help you as much as it is today. So strict is basically an umbrella flag which sets lots of other flags behind the scenes. So you can configure these manually if you want, but strict is a really useful flag because it not only opts you into true for all of the existing strict flags, it also automatically opts you into the future ones. So whenever TypeScript introduces new features which improve the type checking, they'll automatically be turned on because they're under the strict umbrella as well. If that were to happen and it breaks your code base and you think, oh, I want to upgrade, but I don't have time to fix this now, what you can do is you can keep the strict true, but you can actually toggle off individual checks within that. So for example, if you added strict function types, I think actually they had a problem with this at Google when they upgraded. Strict function types would have been too painful for them to fix before the upgrade. So they actually kept strict true on and they disabled strict function types temporarily. So particularly strict null checks, I would make sure you have that on, but no implicit any is also a very useful one under the strict flag. If you can have strict true enabled, make sure you do. One thing I've talked about a little bit is the language service. This is another part of the TypeScript project. This is a node server, basically, that runs anywhere. So we know it as running in the background of Visual Studio Code, but there's no reason why it can't run anywhere. It's used by any editor or IDE that leverages TypeScript. So it basically keeps a cache of the way that your program looks, and as you're typing, it makes the minimal possible update to that cached value. So that's why it can give you sub 100 millisecond feedback. That's their design goal, is sub 100 milliseconds, because that's the point at which humans start to get annoyed that things aren't instantaneous. So that's why it updates as quickly as possible to give you that feedback. So that's why as I was typing, I got a red squiggly line, or it fixed the red squiggly line as soon as I'd finished typing. So very quickly, another thing on that topic. So number 2 here, I've got a TypeScript file. It's wildly different from my last example because I'm very inventive. This time it's lowercasing my last name instead of uppercasing my first name. So this is just TypeScript now. We're dealing with a TypeScript project which I've configured with the tsconfig.json. I have basically just copied the tsconfig from the last example, except this time I'm just compiling my whole source with the TypeScript files in it. As you can see here, I have got my JSDoc annotation in here. I haven't added a type annotation to the S yet. And because we're in TypeScript here, the process of the JSDoc annotation isn't quite the same. You can see these 3 dots as well that have appeared underneath my L, so that's kind of interesting. So if I hover over that, you can see that it's giving me the feedback that JSDoc types may be moved to TypeScript types. This is because we're in a TypeScript context, so we can be more clear about we're using these comments for type information reasons. So what we could do here is if we highlight the thing that is causing the error and we get that feedback on, oh, it's not very big, but if you press Command full stop in your editor, or you can obviously trigger this via the command prompt, you can actually trigger a fix in a lot of cases now. So if I do annotate with type from JSDoc, that is going to add the type annotation from here in explicitly to my program. So that's really cool. It can give you feedback that you can improve, and it can also give you automatic fixes. This is all powered by that language service. Now that I've got the explicit type annotation, again, I found the bug. It's the same bug. It's just a different method name, so I can fix that. I can fix that, or I can let TypeScript fix it for me. So I can do the same exact thing. Change spelling to lowercase was the suggested fix, so I can just tell TypeScript to fix it for me. And these automated fixes apply in so many different ways. If you are using imports and exports, and you start using a symbol which you haven't imported yet, TypeScript can automatically import that for you and add it to your program. It can do things such as fixing things on classes, adding missing this words, keywords, that's that kind of stuff. It can do all kinds of fixes, and this is a key area of growth that's happened in the last 6 months to a year. Go back to the slides. So we've spoken a little bit about some of the journey to get here. We've spoken about some of the moving parts that power all of this tooling, how easy it is to get started with JavaScript through the TypeScript compiler. I would say the recent developments and the future is about doubling down on that community aspect. So one really important development that's happened recently, pause for dramatic effect, is that Babel now supports TypeScript passing inside of its Babel parser. This used to be called Babylon. It's been renamed. They now use the @Babel namespace. So I part of the Babel TypeScript effort, but Andy from the Microsoft TypeScript team did almost all of the work. He was a hero for that stuff. So such a cool effort of collaboration. He was able to work from Microsoft, contribute to Babel. He even improved the Babel code base as he was going along, which was the Babel code base leverages flow type. So there was no hint of, oh, we need to rewrite this in TypeScript. It's all about collaboration. So really, really cool. He improved the Babel code base and added support for TypeScript passing. Now, since that core work was done, other people from the community are now contributing to it. In Babel version 7, which was released about a month ago, maybe 2 months ago, that's when that support landed. So you can now install a plugin and a preset inside of Babel, and it will basically work in the exact same way it works with flow type right now. It will strip your type annotations away. Any syntax which you have in your program which is not valid JavaScript, it will strip it away. So it doesn't replace the TypeScript compiler. It replaces the first bullet point I had on the TSC page. It replaces the emitter from the TypeScript compiler. So it will handle transforming your source code into your output, your dist, the thing you want to ship. It won't type check for you. It won't tell you if you've made some of those mistakes like I showed with the method name being wrong. You will also need to run the TypeScript compiler, but just as its type checker function. So you can set no emit on the TypeScript compiler to not make it output JavaScript files, and you can run it in the background as a type checker. So this just helps people who are coming from different stacks, different code bases, to get started with TypeScript. It's all about lowering those barriers to entry. So that's a really cool development and something which will only continue to grow. Definitely typed. I won't speak too long about this, but basically it's a huge community effort. This is growing and growing and growing. It's the single most active project on GitHub in 2017. It's crazy, 42,000 commits from over 5,000 committers. And the way that it all works seamlessly is incredible. When stuff gets merged into definitely typed, so these are basically the .d.ts files, the way that if you use Lodash or something like that, a JavaScript library which was written with no knowledge of TypeScript, these are the types which community members have written, which get overlaid in the TypeScript compiler to say, oh, you're using Lodash get. Well, that has this signature. Those are maintained in this giant repo, and then they're published to NPM automatically to the @types namespace. So if you want to add TypeScript types to your Lodash code, you would install @types/Lodash. And that would give you some type information which the TypeScript compiler can say, oh, there's the JavaScript, there's the typings, I'll just overlay those on top. One really important development was switching to a predictable release cadence. In the past, new versions would come out of the blue, basically. You wouldn't know that they were coming. They might have large changes in them. They wouldn't be very predictable. So it really helps for large organizations, particularly when they can predict, okay, in a couple of months we'll have the next version. It will therefore be relatively small, bite size. I can upgrade without too many issues. Clear upgrade paths, clear blog posts from the release, and they work, as I've mentioned a few times, in close collaboration with VS Code. So that means that when VS Code releases, it will have the latest and greatest TypeScript version. They work together, there's no surprises. But if you're feeling adventurous, you can always work on the latest and greatest. A lot of people do this, and a lot of the issues are caught very early on as a result. TypeScript @next allows you to bring down the latest and greatest from the project. One recent development is around how do you scale things like giant monorepos. Often you might have something which is rebuilt a lot of times in order to power other things. You might have a dependency graph, which one of the nodes is particularly intense in how many other nodes depend on it. So the actual source of the inspiration for this was the TypeScript compiler itself, the project, the TypeScript project itself. So here you can see the compiler sat in here, and this is actually built 5 times during a TypeScript build. So if you were to run a build on the TypeScript project, the compiler would have to be built 5 times because of all the other things that depend on it. What they realized was that they can use the outputted .d.ts file of a particular input. So let's say the compiler, the public API of the compiler. If that doesn't change, why do I need to rebuild it for the other things? So that's what they realized. They could use the outputted .d.ts file as a source of truth. So basically, they've got this new concept called project, so you have to wire it up in your tsconfig.json to reference the things that depend on things, but it's not too much extra configuration, and then you benefit massively. So now when they run a build, the TypeScript compiler only gets built once, and everything else knows it doesn't need to be rebuilt. So it went from, I think, 4 minutes to 30 seconds or something to build. So really, really cool development. And if you have that kind of project, or if you have a large monorepo, this is definitely something you'd want to check out. The roadmap, if you're curious to learn more about what's coming very soon, is available on the GitHub repo on the Wiki tab, or you can jump to that URL. Some of the things to call out are ECMAScript proposals. So I mentioned that they really want to stay close to ECMAScript and not invent their own features, but it means they need to keep a close eye on what is actually coming. So when things reach stage 3 of the ECMAScript proposal process, in other words, they're 1 away from being implemented, the big int is one such example. It's reached stage 3. So that is the point at which it will be considered to be implemented in TypeScript. So they'll be implementing support for the big int syntax, and then kind of some legacy stuff. TypeScript had decorators and private fields on classes way before they existed in an ECMAScript context and a JavaScript context. They now do exist in a JavaScript and ECMAScript context. They're not fully published in the spec yet, but they're very, very close. So at some point, TypeScript is going to need to support decorators as they exist in JavaScript and the private fields, because they're a little bit different. There's no private keywords in the JavaScript version. There's like a hash symbol and stuff like that. So some stuff, they won't break old TypeScript code bases, of course, but there'll need to be an alternative way of writing that, I think, or at least, at the very least, an emit appreciation for that. And many, many more refactoring helpers, auto fixes. Some of my favorites that I've seen recently, other than the ones I demoed, You can take promise-based code where you've used chained thens and catches. You can now automatically refactor them to use async await, for example. So they'll be adding lots and lots of fixes and auto-refactoring helpers. Oh, thanks. And that'll be coming very, very soon. Thank you.